Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, this is a pre recorded session this week as I am traveling. But if you do have any questions, if you're watching on Zoom, just reply to the confirmation email that you got when you registered. If you're watching on YouTube, just leave a comment under the video. And if you're watching on Facebook, same thing. Leave a comment under the video, and I will get to those questions when I return. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 11 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, so I had about 30 different franchisees I worked with, as well as the shops that they service in order to help everyone get the most out of their diagnostic needs. And before I did that, it was 8 years at Subaru. So worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my way. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is modern ABS systems diagnosis and repairs. We've talked about ABS before a while ago. It was a few years ago we went through this. But if you think about it, ABS is more than just safely stopping a car without skidding, right? It's a lot more integrated into other systems on the vehicle now. So we have our ABS, which was the originator of this. And then we can use that for traction control. We can use it for stability control. We can use parts of it for hill descent control, hill hold start assist, corner braking control, trailer brake control, trailer sway control, automatic emergency braking, intelligent cruise control, those ADAS functions that we may need them for. So you can see it's very well integrated. And these systems are very intertwined on a modern vehicle as well, as many different sensors that share inputs from other sensors and other modules on the vehicle. So when we're diagnosing an ABS problem or repairing ABS, pretty much any vehicle nowadays you're going to find is going to, any modern vehicle is going to have ABS on it. But we just have to be aware of and thinking about the different ways that these systems can affect each other, especially with ADAS. So if we think about how it kind of started with these auxiliary uses for ABS, other than just keeping the brakes from locking up when you have to do an emergency stop. So ABS, yep. So that's going to obviously slow the vehicle down. Traction control is so I can go forward. Maybe I'm on sand or snow or something like that. It'll actually, pump the brakes and keep the wheels from skidding, spinning, and allow you to get more traction that way. And then stability control, different ways so it doesn't skid out or anything like that. So that's where it started. Now we have all these other things kind of related to it. And since all these systems do work together and they do utilize the ABS, we do have a multitude of sensors and sub components that we have to worry about as well. So we have the wheel speed sensor, of course. That's kind of that's been around the longest, I think, out of most of these things. Steering angle sensor, so the computer knows what angle the steering wheel's at. Steering effort sensor, so am I steering it quickly and with a lot of force, or am I just going very lightly? Brake pedal position sensor, because it's not really a brake light switch anymore. It's more of a pedal position sensor. I'll actually show a picture in a little bit. Brake pressure sensor, so it knows the pressure in the brake fluid. Yaw rate sensor, which senses the kind of the back and forth of the vehicle. Hydraulic unit, which is of course the pump and the solenoids and everything that actually makes the brakes pump. The control module that controls it all, and also ADAS components, as we said, are fed into this as well. So things like cameras, radar, whatever other sensors there are on the vehicle for the ADAS, that would be related, and a failure in one could lead to a failure in another, and you wouldn't want to misdiagnose that as the wrong failure. So we take a look. This is actually not a terribly complex system. It's in a Ford Explorer. There's not a ton of inputs and outputs, but we can see, there's the ABS module, gateway module, instrument panel cluster, HVAC, etc. All of them kind of communicate over the bus and may need that may need that input or may need an output to the ABS as well. IPMBs, that's image processing module, that's for like camera. Hydraulic pump motor and valve solenoids, of course, for the ABS hydraulic unit. Hydraulic pressure sensor, actuator position sensor, brake fluid level switch, wheel speed sensors, etc. So all of this stuff is intertwined and related to each other. So let's talk about some of the different components, separately. So we'll have the wheel speed sensors, and they can be analog or digital. And in the analog realm, they're usually going to be inductive, and in the digital realm, they're usually going to be of a magnetoresistive type. So an inductive sensor works, but it's got a coil and a permanent magnet in there. And as this rotor goes by, ferromagnetic rotor, which means iron, it's got iron in it, anyways. It's ferro is iron. Uh, it's going to induce a current into this coil, which will then send a signal down the shielded cable to the module and do what it needs to do. So as it spins, you're going to get the up and down little sine wave action going on. So it's going to induce that. Now, one common problem that these can have is when we have some sort of contamination, rusted rotor, broken or chipped tooth or two on those rotors can cause a dropout in the signal, kind of like this. So when it sees that, it says, "Oh, well, I don't see any motion. I don't see any movement. That must mean the wheel is locked." According to the computer, would think that the wheel might be locked, and then it might unapply the brakes and then reapply, unapply, reapply. So this actually happened on my mother's car a long time ago. She had a 2001 Ford Explorer, and every time she would come to a stop, like down to like 5 miles an hour or less, I guess, getting close to a stop sign, um, it would act like the ABS was firing no matter what. It could be perfectly dry, 80-degree summer day with nothing on the road, and it would still fire the ABS. I mean, you could feel it in the pedal, you could hear it buzzing and whatnot. So it took them a little while to figure out, but when they did, what they did find out was that this had happened. So on the end of the axles, it had those uh, tone wheels on the end, and one of them got really rusty just from being in New England. I guess that's kind of the problem. That's a problem up here. So it would cause a dropout in the signal, and all you got to do is replace the tone ring or what have you, and then that's the problem. But a good thing to check, and you would actually be able to see it on a scope. So there's actually got a component test for that on an 01 Ford Explorer, and it is analog. It's just plus and minus. So you just go on the pins, and then you would see the small voltage that it would induce. Now, as the speed changes, the frequency and the min-max voltages will change. So it basically, the faster it goes, the closer together the bumps are going to get, and the taller the bumps are going to get. And then as it slows down, the bumps will get smaller and they'll spread out. So it's a frequency thing, how fast that wheel is turning. And then we have magnetoresistive sensors. So this is kind of the passive sensor that we were just looking at, right? Where it's got the magnet and the coil, and it just feeds and induces a current in there. So it's passive, like I said, it's not being supplied anything. It's generating it on its own based on the magnetic field. But on a magnetoresistive sensor, it is active, so it is supplied power. It has an integrated circuit in there, and then we have two different sensors. And on the rotor, usually on the inner bearing race, oftentimes it's part of the hub assembly now on many vehicles. It's going to have an encoder ring with north and south poles all the way around it. So judging by how the magnetic field affects these two sensors, Hall effect sensor, they send a signal out, and it's going to generate it's going to basically make a signal that goes to it's going to send out a square wave. So this can also be used for direction detection. So computer might want to know, are the wheels going forward or are they going backward? So as long as the magnet is in the right orientation, it's going to come through here, and we see south north. So north is going to hit A first, then B, A first, then B, and so on. So that will generate a signal, and then B will generate a signal shortly thereafter. There'll be a little bit of an offset, of course, but it's going to hit the first one, and then it hits the second one. So it generates a square wave in that case when A goes high first, when A gets a signal first. When it's going backwards, though, B is going to get a signal first. So it is going to put out a modified square wave where you see how it kind of has a bump and then a dip and then a bump and then a dip. So that would indicate to the computer, if it gets that type of signal, that the wheel is traveling backwards. If it gets the other signal, wheel's traveling forward. So here's just an example of that, right? So it's on a 2019 GMC Acadia. Wheel speed sensor is 12-volt digital sensor. Electronic brake control module sends a 12-volt reference voltage signal to each wheel speed sensor. As the wheel spins, the wheel speed sensor produces a square wave DC signal voltage. The wheel speed sensor increases the signal frequency as the wheel speed increases, but does not increase the amplitude. So you would see a square wave that is not going to get taller, but it will get further apart or closer together depending on how fast it goes. So it's going to be the same voltage range, about 1.5 volts there. But it's either going to be a lot closer together or a lot. And then also note on those, there's a bulletin on this as well. So it says on some vehicles, the following DTCs or symptom codes may be set, and it lists them. In addition, the following lights may be illuminated: ABS, service traction control system, and/or service stability track. This may be caused by bits of ferrous magnetic debris stuck to the wheel speed sensor magnetic encoder ring. Remember how we talked about how that is made? And the encoder ring is a magnet. It's a bunch of magnets all together. And eventually, over time, you're going to pick up little bits of metal fragments and stuff like that. And I would imagine they're usually in a knuckle. And the knuckle's usually made out of steel, and steel rusts. So you get rusty metal flakes on there as well. And that will cause an issue, cause an interference with the sensor. So these vehicles use a speed sensor encoder ring with north-south magnetic pole pieces encased in a nitrile rubber ring, usually brown in color. This ring is part of the wheel bearing. If you experience any of these symptoms, this ring may be cleaned using a soft nylon bristle toothbrush or equivalent. If any debris still remains, a mild soap detergent may be used. Wipe dry after the procedure. Use care to prevent damage to the wheel bearing seal, so don't use the brass brush. It is important to not use any kind of magnetic tool either to remove this debris, or the encoder may be damaged. So you might think, oh, it's just a bunch of metal flakes. I'll just take my magnetic pickup tool and just sweep around it and that'll be good. Well, it's going to mess up the encoder ring that's there. It's going to mess up, play funny with the magnetic field in those magnets. So we don't want to do. And here is their artist's rendition of what that might look like. It's not the best in the world. It's kind of CG, but it would look kind of like that, right? You're going to have a bunch of debris around the inner bearing race, hub assembly. Also need to be careful on some vehicles that the speed sensors may be left and right. They may be direction dependent. So in this case, it's on a Volkswagen Passat, and if you swap them or you put the wrong one in the wrong hole, might make contact with the back of the bearing. In this case, you can see where it kind of rubbed on there. And then now the encoder ring is all destroyed. You can see it, so it's kind of worn off between those two red circles. They put those in there. That's not part of the bearing. So it's in between there is what they're trying to call your attention to there, where it's all wrecked, tore up there. So we got to be aware of that and be careful. All right, and here's just another example on a 13 Dodge Chargers. This one kind of makes its own very small voltage output signal. So as the wheel spins, the sensor will produce a square wave that varies by about 400 millivolts, cycling between 10.4 and 10.8 volts, and the meter is set to focus on that pattern. So it's going like a negative 0.4 up to a positive 0.4, and that's about how far it's going to cycle. So it's very small changes, and this was just spinning the wheel by hand, so it's a little erratic, but this is what it would look like spinning it by hand. And then on a newer vehicle, 2021 Hyundai Palisade, this is a good advice for a lot of different newer style ABS sensors or wheel speed sensors. Do not unplug connector while the key is on. The ABS control unit shuts off voltage if the sensor is unplugged. If codes are stored, clear the trouble code first before performing tests. It's recommended to use a scanner to check the wheel speed sensor PID data streams. Inspect electrical connectors for looseness and poor male to female terminal fit. Make sure air gap between sensor and tone wheel is correct. Check speed sensor and tone wheel for debris or damage. So that harkens back to the GMC. Carefully inspect speed sensor harness for chafing against suspension components. Voltage at the power terminal of the active hall sensor will be approximately 0 if a DTC is set for that wheel speed sensor being tested, or if the sensor is disconnected. So basically it cuts off the power if it has a code, or if it becomes disconnected. And you can't resistance test it because it's got an IC in it anyways. So really the best way, if you're gonna test it with a scope, you need to plug it in, have it plugged in, and you need to back probe with it connected. Otherwise, you can use PID data. Let's talk about some other sensors. So yaw rate sensor is going to sense this kind of motion, the nose motion of the vehicle, whether it's turning left or right and how it's going. Yaw rate and G sensor detects changes in vehicle direction. It detects the motion by moving electrodes built into the sensor. Sensor will send ABS control unit a signal by changing the voltage. So you can see that's mostly CAN communication in that case. Also on some vehicles, a multi-axis acceleration sensor. So yaw rate and lateral acceleration sensors are combined into one multi-axis acceleration sensor module, external to the electronic brake control module. EBCM receives serial data inputs from the yaw rate, longitudinal, and lateral acceleration sensors. So those also need to be reset, and we'll talk about that in a little bit. Output serial data to the electronic brake control. Then we have the steering angle sensor, right? So that just tells the computer where is the steering wheel based on 360 degrees or whatever. And we have positive and negative degrees that can read through there. So that's usually up by the steering wheel and the clock spring. Sometimes it could be down at the bottom by the steering rack. There also could be a torque effort sensor in this case. This is on a GMC as well. So this measures how much effort is being applied to the steering wheel in order to make the vehicle steer. And with electronic racks as well, there's even feedback that can be had as well, where it provides effort to the steering wheel. So it gives you feedback to that in there. Then we have brake pedal position sensors. So as I said before, it's not a brake light switch anymore. It is a brake pedal position sensor. And you notice it looks a lot different than a stoplight switch too. Basically a rheostat, kind of, in a way. Pot. Think about kind of like a throttle position sensor. We work in the same principle, right? Where it's got varying voltage across or varying resistance and changes the voltage output. So this would ride on a piece of the pedal, maybe the rod or whatever, and then it's going to output to the modules that need it. It can be more than one module. In this case, it's GMC. Body control module monitors the brake pedal position sensor and sends a serial data message to the electronic brake control module when the brake pedal is applied. The electronic brake control module compares the correlation between the brake pedal positions and the brake control brake pedal position sensor to sense the driver's application of the brake pedal. Body control module turns the brake lights on when the brake pedal position sensor changes state. Okay, so it's in the capacitor compartment on the left side of the instrument panel attached to the top of the brake pedal assembly, which makes sense. Then we have pumps and hydraulic units. So these are the, if the modules, the brains, these are the brawn. These are the ones that are actually opening and closing the valves many, many times a second in order to pump the brakes and apply pressure and release pressure. So you got a couple accumulators in there and you got a bunch of open and close valve. So there's kind of what it would look like by itself. And then the control module goes on the other side. It's this piece here is the control module. So there's all my different solenoids, and fluid goes in, fluid goes out. So it's going to work kind of like this. So this is a simplified animation of that. So I'm going to press down on the brakes, and the ECU is going to send a signal to this to maintain the pressure on the brake pads. Right. So it's energizing the solenoid here, and it sends the pressure down, and it maintains the pressure. Now, if we suddenly get into a skid, which will happen here in another second or two. So that's the wheel speed sensor right there spinning. You can see the time going. And then if we need to pump the brakes, it's going to reduce the pressure. It'll bleed some of it off by opening and closing this valve right here. So it's going to push it and let it bleed off. And you'll see how it's kind of bleeding off out of here as well. We got this little accumulator that will bleed off out of that and back into the reservoir. That's what pumps the brakes when we're doing that. Building and relieving pressure, and then finally it'll build the pressure back up in the system again, and then it goes back to normal state. And like I said earlier, ADAS components very important as well, or it's at least they're used in conjunction with each other. So think about intelligent cruise control. It's going to slow the vehicle down if it needs to slow the speed down. Also with advanced emergency braking. So say I have a vehicle 3 cars ahead of me that I can't see because there's a truck there in front of me or something, and they slam on their brakes for some reason, emergency procedure. The vehicle with the radar and whatnot can detect that another vehicle has stopped ahead, and it'll slam on the brakes for you as well, and stop the vehicle automatically. So it's all good things for safety, but if I have a failure in the ADAS, it could cause some sort of other issue with the brakes and vice versa. So an issue with the brakes, it can cause ADAS problems. So we just have to be aware of how everything's really connected nowadays on the vehicle. All right, so let's go live on the tool and we'll take a look at some things. So first thing I want to mention is first thing that popped up on the screen there actually. So if you have a snap-on tool with guided component test in it, so it's any of the tools with a scope. So Modus, Triton, Vantage, Zeus, go in there. And if we go into our main database, before I ID a vehicle, there is a classes button. This will bring you right to some built-in classes. Some of them are for ABS. So if we go into how to, scroll down a bit, and then we see the first 20-minute class is a 20-minute anti-lock braking class. You learn about operation, basics and fundamentals, testing active and inductive wheel speed sensors and how to test them. And then if I scroll down again, down in here, 20-minute brake electronics class. So this is an appendix to the other one. So a number of extra components have been fitted to vehicles with anti-lock brakes or ABS over the last number of years. This allows extra safety features such as brake assist, electronic stability program, etc. to become available. Following section is an add-on to the anti-lock braking class and is designed to explain the function of these extra components. So we can go through here and see the different things that it does. Different acceleration sensors and steering angle sensors and so on and so forth. It walks you right through it. And it's all readily available to you on the tool. You don't have to ID a car or anything. All right, let's look through some vehicles now, and we're just going to progress through time. So we'll start with the 2001 Ford Explorer, which has anti-lock brakes, 4-wheel anti-lock brakes, codes, data, functional tests, and some troubleshooter actually. But if we go into functional tests, there's actually a bleed brakes mode. It's an automated brake bleed procedure. That's pretty good for 2001 to have that. Pump motor test, which is going to turn the pump motor on and off, test it. And then various output state tests, such as the inlet valves and the outlet. It'll function on open and close. Make sure they work. As far as data display, it's kind of funny. 5-hole PIDs. Remember those days back when you only had 5 or 6 things? And now you could have 500 or 600 different things to look at. So this is this up. Nice and easy. So we got, it's a 3-channel 3-sensor 4-channel setup. So you got left front, right front, rear wheels together, all your wheel speeds. And then looks like it's doing a kind of maybe a small burnout here. DTC count and BOO, which is a brake on-off switch. So that's all you get, and that's really all you need because it's a pretty simple system. Now it's scanner stuff. What about component test stuff? So we have an ABS category and ABS 4-wheel 3-channel. So we got ABS module information, such as like the pinouts, stuff like that. General component information, module location, left rear of the engine compartment, brake fluid level switch, brake pedal position switch, parking brake switch, wheel speed sensors. So these are the inductive sensors. Uses 3 variable reluctance sensors to determine vehicle speed. Sensors are located on the right and left front wheels, and 1 sensor mounted on top of the rear axle housing. Anti-lock brake sensors operate on magnetic induction principle. As the teeth on the anti-lock brake sensor indicator rotate past the stationary sensor, a signal proportional to the speed of the rotation is generated and sent to the anti-lock brake control module through a twisted cable and shielded wiring harness. All right, and then we can come down here. A couple tech notes too. Some sensors fail intermittently, kind of like my mom's. May need vehicle at normal operating temperature to isolate failure. Road testing vehicles on rough or uneven roads may help with diagnosing intermittent problems. Road test the vehicle using a scan tool. Look at the wheel speed sensor PID data if available. Look for any erratic reading. Also compare sensor readings. They should be close within plus or minus 2 to 3 miles per hour. Good to know. All right. Next one, we'll do the 2011 Forester. So on these, we don't get everything in the simulator on this, but we can get some indication of some things. If it has VDC, as vehicle dynamics control, stability control. There are usually additional functional tests in here as well for like the G sensor or the yaw rate sensor. ABS sequence control, though, what that's going to do is you're going to hold down the pedal. You need the engine running. You're going to hold down the pedal, and it's going to pump through the different, the different wheels and pump the brakes for you. You actually have to hold down the pedal as hard as you can, and then it pushes back, and you feel it vibrate and do the noise cycling through the solenoids. All right, and then if we think this is 10 years newer, we got more data. Right, G sensor, wheel speeds, of course, vehicle speeds, valve relays, motor relays, etc. So a little bit more data there. And let's go to got a component tests, ABS, and you see a few more things like the yaw rate sensor. So it detects changes in vehicle direction. It detects the motion by moving electrodes built in a sensor. Sensor will send ABS control unit signal by changing in voltage. And communication there. G sensor output tests, going to tell you what you should see. The RHG sensor installed, the value store should read anywhere in there. Unbolt it and angle it 90 degrees forward, rearward, left, and right. G sensor should read that. So that's actually testing it with the scan tool, not the guided component test, but it tells you how to do it. Brake fluid level, brake light switch. All right, same type of deal, 12-volt reference and a switch signal, and then a light signal. Very simple. Back there. Wheel speed sensors on these are going to be tone wheel for the ABS and VDC has been removed. It's actually part of the from the axles and been replaced with an encoder ring that is fixed to the wheel bearing. So it's actually part of the wheel bearing. The speed sensor has been redesigned to work with the encoder ring and mounts through the wheel bearing housing. It's a Hall switch type. The encoder ring is adhered to the wheel bearing outer shell and is not serviceable. Small magnetic strips are incorporated in the encoder ring to provide the pulses to the speed sensor as the wheel rotates. So that is a magnetoresistive. Okay. It's the Subaru. Get a little newer. We'll go to the Acadia 2020. And we'll go to brakes. Codes data functional tests. We got an automated brake bleed procedure on this as well. Just going to walk you through bleeding the brakes. That includes bleeding the hydraulic unit. Output controls, different pressure sensor calibrations, parking brake actuators, right? If you think about parking brake, you might need to extend or retract the pistons on the brakes if you're doing brakes. And the other important thing to understand about this, because I get a question about this like once every other week. Retracting the calipers is not necessarily retracting the calipers. It depends on the manufacturers how they do it. Some of them, it actually retracts the parking brake, physically pulls it in. You don't have to worry about it. It just does it. You replace the pads, and then it goes back. Others, it retracts the mechanism, but you still need to push in the piston. Others, you still have to screw in the piston after releasing the mechanism electronics. Many different ways. Just understand it's not the same on every single manufacturer, and read up on the way to do it on a particular manufacturer if need be. Some manufacturers still don't even need it. Because maybe if you think about like disc brakes on some vehicles have a drum parking brake on the inside. So if you're not changing the drum and you're just changing the disc pads, you won't even have to do anything. So it just depends on how it's set up, how it's built. Now let's go to got a component tests. And ABS. You see brake booster vacuum sensor, electronic brake control module itself. It's going to give you all the pinouts. You can see it's quite a few. Brake pedal position sensor, talked about that a little bit earlier. Body control module monitors the brake pedal position sensor and sends a serial data message to the electronic brake control module when the brake pedal is applied. The electronic brake control module compares the correlation between the brake pedal positions and the brake control brake pedal position sensor that sense the driver's application of the brake pedal. Body control module turns the brake lights on when the brake pedal position sensor changes state. Also used for hill start assist feature. The other section of the switch controls the rear brake lights. So we can see all the different pinouts and such. And then we have a voltage test we can do for 12 volts. Let's check that. Parking brake switch, wheel speed sensors again. This one's going to be the 12-volt reference to each wheel speed sensor. As the wheel spins, the wheel speed sensor produces a square wave signal voltage. Wheel speed sensor increases the signal frequency as the wheel speed increases, but does not increase the signal amplitude. We talked about that. And then this is the one the bullet goes on. The signature test, maybe. It's on the older one. But yes, many tests available for that. And then the last one we'll do is that Hyundai Palisade. Go in here. And brakes. Data. Let's look at the data. Look at that. This is our newest vehicle, so it has the most data out of all of it, right? The newest vehicle that we're talking about. So there are some system tests in here. Air bleeding, once again, does a brake bleed procedure. G sensor calibration, steering angle sensor calibration is under brakes, not steering. Actually, it might be under steering too. But in this case, it's related to steering angle or steering related to the brakes. So sometimes you need to check in there too. Brake pad change mode, once again. So in this case, before changing brake pads, this function should be performed. This will allow you to push the piston into the caliper by retracting the spindle nut with the actuator. It does not retract the piston. You have to physically push the piston in. Once it's done, you need to do the after pad change function. And I'm not going to go through it because it takes a while. I have to wait for like 20 seconds. So it releases them, and then that's to put them back when you're done. As far as guided component tests, ABS module, once again, there's even a location image on this one. So it's in the back by the firewall. There it is right there. That's what it looks like. Pinouts, of course. Electronic parking brake actuator. You can actually go in there, and there's a test for that. Brake fluid level switch, traction control, wheel speed sensors. Again, let's see what kind of wheel speed sensors we have on this. Hall effect switch measures vehicle speed by measuring a reluctor wheel located on each wheel. And then if we come down here, do not plug the connector while the key is on. The ABS control unit shuts off voltage if the sensor is unplugged. So we talked about that earlier as well. So I guess the best word of advice is to understand that all of these systems are interconnected nowadays. Fault in the ABS could affect other systems. Fault in other systems could affect the ABS. There's different ways of testing it, depending on what kind of component it is and what kind of system it is. You may or may not have to do brake pad change modes and things of that nature, and those can be different as well. So just do your research, especially even on the same brand, it can be different. So just make sure you're reading what's on the screen when the scan tool tells you, or reading your repair information and what have you. And that'll help you diagnose it a little bit better and not make those mistakes you might make. So that is ABS. Let's talk about what we're going to talk about next week. Next week, we are continuing on our OEM-specific training. And next week's topic is Volkswagen and Audi, actually Porsche too. So we'll call it Volkswagen Audi Group, VAG. So same time as usual, same place, every Tuesday, 6 and 9 Eastern. Go to snapon.com/OT to register to sign up for Zoom. Otherwise, you can watch the 6 p.m. Eastern class on YouTube. 9 p.m. Eastern class goes to my Facebook page, which is facebook.com/snaponjason. If you want to see any of the other classes in this series, we have 87 of them. This one's class 87 right now. Anywhere from intro to ADAS to our OEM specific training series we started this year as well. If you want to subscribe on our YouTube channel, just scan that QR code right there. It'll bring you there and subscribe you. Otherwise, you can go to youtube.com/Snap-on Diagnostics. There is a playlist for the live training as well. As for questions, as I said, this is a pre-recorded meeting today. So as I am traveling, so if you have a question on Zoom, just reply to your confirmation email. If you're watching on YouTube, just leave a comment underneath the video, or same thing with Facebook, leave me a comment, and I'll get to those when I can. Also want to remind you about my buddy Keith. He also does training on diagnostics Wednesdays and Thursdays. So Wednesday is on Zeus and Thursday is on Apollo and Triton. Very thorough class, meant to have the tool kind of in front of you and function through the tool while he's functioning through on the screen as well. First hour is going to be scanner functions mainly, setup functions, that sort of thing. Then he takes about a 5-minute break. And then after that, he goes through all the scope and meter functions on the corresponding tools as well. So definitely check that out. snapon.com/OT for that. And then with that, thank you very much. Thank you for taking a little bit of time out of your day to spend a little bit of time with me. Hopefully you gained a little bit more knowledge on air conditioning systems and how they work and how we might be able to test them. Enjoy the rest of your week. Enjoy your weekend. Have a good night and take care.